Hi, welcome to a presentation about the wire walker, a vertically profiling float, powered by ocean waves. The wire walker was developed by the Ocean Physics Group, which is part of the Marine Physical Laboratory here at Scripps Institution of Oceanography. The wire walker was conceived in order to address a problem regarding sampling in the upper ocean, and that is that the ocean evolved in 3 spatial dimensions, as well as in time, while a typical oceanographic sensor can only measure the time variability at a single point, its location. Therefore, in order to estimate spatial variability, a number of sensors are needed, as well as a way of positioning those sensors in space. Independent of the cost of the sensors themselves, this deployment effort is often extremely expensive. Wire walker provides a solution to this sampling problem. The wire walker is a low-cost, easily deployed platform which uses wind and surface waves to drive vertical profiling. Therefore, the wire walker can enable any time series instrument to profile vertically, creating a 2-dimensional record in depth and time from an instrument that otherwise would only produce a 1-dimensional record. Using the ocean waves, the wire walker can travel relatively quickly and can sample over a range of depths more rapidly than the natural variability in much of the upper ocean, allowing for a relatively complete characterization of that variability. This is a video of the wire walker descending a wire. The wire is moved vertically up and down by the surface buoy and the bottom weight, ratcheting the wire walker downwards. When it reaches the bottom stop, a cam is released, and the slightly positively buoyant wire walker ascends up the wire. This is an early prototype version of the wire walker, and in white, attached, is a temperature and pressure recorder. The newer versions of the wire walker have carried all manner of oceanographic instrumentation, including biological instrumentation. Once the wire walker reaches the surface, the cam is re-engaged and the profiling, ratcheting down to the bottom, begins once again. This is a record of ocean temperature versus depth collected in 2007 from the Indian Ocean, from a single wire walker with a single instrument mounted on it. The 400-meter round trip from the surface to the bottom of the wire to the surface again took approximately 20 minutes and was therefore repeated 270 times in 4 days. The vertical motion of the isotherms, noted here by the blue arrows, is due to the propagation of internal waves through the upper ocean. The wire walker is an excellent platform to observe variability in the upper ocean due to the internal wave climate. On that same wire walker was mounted a fluorometer which measures the concentration of chlorophyll in the water. This is a plot of the concentration of chlorophyll versus depth over that same record length. And from this plot you can see the variability in the depth and intensity of the deep chlorophyll maximum as is related to the propagation of internal waves. The wire walker design has evolved significantly since the original prototype seen in the video. In 2004, we were using a closed case design with buoyancy and cam mechanism inside of a large plastic tube. By 2007, we moved to a more modular design, where the frame, rollers, and cam are separated from the buoyancy and instrument-containing tubes on the outside. The newest version of the wire walker, the 2009 version, is a fully modular design where the instrumentation, data logger and batteries, and cables can all be removed, cleaned, and serviced between deployments, increasing the utility of the wire walker package. The wire walker in this picture is currently deployed off of Imperial Beach, California, and has, over a 3-week period, made 30,000 profiles in 13 meters of water. On the wire walker is mounted a conductivity temperature depth sensor, an optical scattering sensor with a number of different wavelengths, and a radiometer. And this instrumentation package is participating in a pollutant dispersal study and gathering data for a student's PhD thesis. Marine protected areas and other coastally sensitive areas often require intensive monitoring efforts. The wire walker is a perfect platform to the deployment of instrumentation that can help manage and protect coastal resources. We are currently working on implementing real-time data transmission, either via high-frequency radar or satellite transmission. This would allow us to pass data directly from the instrumentation to the laboratory or desk and be able to make real-time decisions given the state of the upper ocean. The wire walker can also be deployed from the ships and need not be moored. We envision arrays of wire walkers being deployed with their low cost and relatively robust technology, creating a network of sensors, profiling, and measuring variability in the upper ocean with very high resolution. The Ocean Physics Group, in addition to making wire walkers, also works on high-powered Doppler sonars and measures ocean currents from them. Thank you very much.